Welcome students to the Electronics Engineering Workshop Lab. Today we are going to do the first experiment, that is familiarization of electronic components. When we talk about electronic components, we should know that they are classified into two, the passive components and active components. Passive components are components that are capable of amplifying or processing an electrical signals by themselves. Some of the examples are resistors, capacitors, inductors. Whereas it comes to active components are capable of amplifying or processing signals by themselves. Some of these examples are diodes and transistors, etc. In active components, the resistors are further divided into linear resistance and non-linear resistance. In linear resistance, it is further classified into two, there is fixed resistance and variable resistance. In fixed resistance, you can see a carbon resistor and its fixed resistance symbol is as shown here below the carbon resistor. And for a variable resistor, you use a potentiometer which is a variable resistor and its symbol is shown below the potentiometer. For a non-linear resistor, we use an LDR which is a light dependent resistor, and it is a non-linear, that is, according to the incident light, the resistance increases or decreases. And thermistor is a device, according to heat, the temperature decreases or increases and the resistance value increases and decreases. In fixed resistors, you can see a carbon resistance over here, and it has a color coding on its surface. The color coding, to decode, we need a chart of this shown here. For each color code, there is a certain value in this chart. Before it, you should understand that the color coding for the resistance has a certain band of colors which is imprinted on its body. Over here, you can see there's some color of brown, black, and orange and gold imprinted on the resistance. So here in color coding, the first band is brown, second is black, third is orange. And according to the chart, you can see the brown value is 1. And the second band, the black value is 0. So you write it down as the first band as 1 and the second band as 0. The third band indicates a decimal of multiplier, that is, according to the chart, the third color, that is orange, is a multiplier of 10 raised to 3. So you can write it as 10 into 1000. Over here you can see it, which is somewhat 10,000 ohms or 10 kilo ohms, which are, and then the fourth band is a gold, which is having a tolerance of plus or minus 5%. Hence we can decode any resistor according to this using this chart. Variable resistors. In variable resistance, you can change the value from 0 to the value indicated on the resistance of the resistor used. Here we use a potentiometer which is used for controlling purpose. Using this we can control the volume or decrease the brightness of any devices in which it is used. A potentiometer is also known as a pot, which is a short form, and the specific value of resistance is imprinted on its surface. Over here you can see a 1k resistance, 10k resistance, and a 100k resistance imprinted on its surface. It has three terminals. Over here you can see the input terminal, the output terminal, and the ground. And it has an adjustable knob over here. By adjusting this knob, you can control the resistance from the resistance value imprinted on its body. That is from 0 to some whatever the resistance it is having on its body. A non-linear resistance, when you talk about the non-linear resistance, an LDR is a resistance which is an light dependent resistor, also known as a photocell. It works according to the principle of photoconductivity, that is, it's a light control device. When light is incident on this resistance, on this LDR, the resistance decreases with increase in the light of incident on it. It is normally used as a light sensor device or a dark sensitive switching device. On top of this LDR, a cadmium sulfide track is placed so that when the light is incident on this, it has a smooth conductivity of current. Next non-linear component is a thermistor. It is a semiconductor material used which has a extremely high sensitivity to the temperature. A small change in the body temperature of the thermistor makes it to change an appreciable change in resistance. Thermistor may exhibit a positive or negative temperature coefficient of resistance, but mostly used thermistors are negative temperature coefficient 1. Capacitors. The capacitors are used to store an electrical charge. It may provide a low impedance to the AC or high impedance to the DC inputs. They are classified also into two, the fixed capacitors or variable capacitors. In fixed capacitors, you can see there are ceramic capacitor, which is also known as a disc capacitor, a electrolytic capacitor, a polyester capacitor. The capacitors may be classified according to the dielectric medium used in it. So here you can see a ceramic capacitor has a name of it from its dielectric material used in it. In this use, it uses a ceramic medium, so it has its name from it. An electrolyte capacitor uses a electrolyte, so it has a name of electrolyte. Polyester film capacitor uses a polyester film, so it has a name of polyester. Fixed capacitors. Fixed capacitors has a value classified according to its dielectric material used, as I said it before. Its symbol is as shown here. A ceramic or a disc capacitor has a capacitance value imprinted on its surface. It needs to be decoded. For example, a 103 microfarad capacitor, a 103 coded capacitor has a microfarad of 0.01 microfarad, and a 104 coded capacitor has a capacitance of 0.1 microfarad. It has no polarities, so it is a non-polarized capacitor, and they are used in RF amplifiers. The decoding of a capacitor, as I have said, is similar to the resistance decoding. That is, the first two numbers are taken as it is, and the third is the multiplier. That is, if you use a 103 code capacitor, it has first two digits are taken as it is, and the Third is a multiplier 10 raised to 3, which has a capacitance of 10,000 microfarad, and you get a 0.1 microfarad capacitance. Similarly, it is for the capacitance of 104 coded capacitor. An electrolytic capacitor, it also comes under the fixed capacitors. The capacitance and the voltage values are imprinted on its body. It is mostly used as a bypass or a decoupling capacitor used in filters. Uh, their applications are in motors, in fans. It is polarized capacitor, but because its leads have polarities, the bigger lead has a polarity, positive polarity, and the negative lead is a smaller one. Polyester film capacitors are used mainly in high voltage applications. They are to a non-polarized ones. Variable capacitor, when you say, we use a gang capacitor. The dielectric material used in the gang capacitor is a air. They are used in frequency tuning purposes in an audio system. These capacitors has plates which are visible on rotation of its shaft. In this diagram you can see that this is the shaft. On rotation of this shaft there is a plate in this plates. These are plates you can see in the capacitors. There is a movement of this plate, and on the movement of this plate and the dielectric medium, which is air, you can get the desired frequency which is needed for an AM and FM receivers. The symbol of an variable capacitor is shown here. Inductors. Inductors is nothing but a wire wound on a coil and on a core. It's wound on a core of a suitable material. It is used for the purpose of sudden change in flow of current, and has the capability of storing in energy. The inductor's symbol is shown here for a fixed inductor and a variable inductor. Transformers. The transformers are classified into two: the step down transformer and the step up transformer. In case of a step down transformer, the winding in the secondary will be less than that of the primary, whereas in the step up transformer it will be just the opposite, or vice versa. The transformer works on the principle of mutual induction. Here you can see the primary and the secondary of a two input two output, primary to input, the secondary to output. This is the transformer symbol. Whereas there is another transformer which is known as center type transformer. That is, you have a two input and three outputs. That is, it is indicated in the top of the transformer as 12 0 12. That is, from this output you get a 12 volt output, and from this extreme end you get a 12 volt output, whereas the center is common for both, which is 0 volt. If you use the T1 and T2, you get a voltage of 12 volts, and if you use a T2 and T3, you get a voltage of 12 volts, and if you use both T1 and T3, and the center of the transformer is used as a neutral one, common one. You get a voltage of 24 volts. So center trap transformer has the advantage of providing more output than the normal transformer. The symbol of a center trap transformer is shown here. Moving on, active components. They are they can amplify or process signal by themselves. They are uses an energy source. Some of the active components are diodes and transistors. The symbols of active components are shown here. Diodes. The main purpose of a diode is to convert AC into DC. It is used in rectification purpose. Diode allows unidirectional flow of current. That is, conduction of current is possible only from anode to cathode. Various types of diodes are silicon diode, germanium diode, Zener, LED, that is light emitting diode. They are made of semiconductor materials. PN junction. Silicon diodes. Silicon diodes has an code of IN4007. Its cathode can be identified by a silver ring coating, which is shown here, which is mentioned as cathode. The direction of current, as I have said, is unidirectional, that is from anode to cathode. Germanium diode has a conductivity of 0.3 theoretically, and its code is OA79. The conduction of flow is from anode to cathode. Zener diode. Zener diode operates just like the normal diode in the forward bias condition, whereas it is normally used in a reverse bias condition. The voltage may be seen imprinted on the surface of a diode. Here you can see a voltage of 5 volt imprinted on the surface of the body of the diode. This indicates that the voltage at which the Zener breakdown occurs, and it is the voltage which the Zener diode is mostly used in. Hence, these diodes are used in reverse bias conditions. That is, even if the current increases, the voltage remains constant after the Zener breakdown. That is the voltage imprinted on the body of the diode. Transistors is a semiconductor device used for amplification and switching purpose. The transistor consists of three terminals which forms an PNP or an NPN junction. A common transistor is a BC107 transistor, which is a bipolar junction transistor, and the identification of this transistor leads can be done by the notch. Here you can see a notch on the transistor, and below the notch the first lead which comes is the emitter. The center lead is the base, and the opposite to the emitter is the collector. The symbol is shown here. The next one is a unijunction transistor which has a number code as 2N2646. Here you can see there is no collector in this emitter. Instead of collector there is an additional base as B2. Similarly, to find the emitter base collector, the Lead closer to the notch is the emitter. The middle one is the base one, and the opposite to the emitter is the base 2. The symbol is shown here. The next one is the BFW10 transistor, which is a junction field effect transistor. The junction field effect transistor has 4 terminals. It doesn't has a emitter, base, or a collector. Instead of it, it has a source, drain, and gate. An additional one is shown over here, that is the substrate, which is used for the grounding purpose. The notch next to the terminal next to the notch is the source, then comes the drain, then the gate, and the substrate. Power transistors. Power transistors are coded with 2N3055. The power transistor that uses for the purpose of high power amplification and power supplies. The transistors are suited for application of audio and switching circuits. To identify the leads of this transistor, which is the emitter, base, and collector, you have to know that the transistor once placed in certain position, you can see that cert the the length of the transistor of in one direction is much more than the length of the other side. Here you can see the length from here to the bottom is much more than the length in the upward direction. In this position, once kept, you can identify this transistor base as this one, and the emitter one is this. And the body of the transistor, power transistor, is taken as the collector. Seven segment display. In 7-segment display, you can see there are 7 segments in this. There is 1, 2, 3, 4, 5, 6, 7. Hence, this is known as a 7-segment display. A 7-segment display is a form of an electronic display device for displaying decimal numbers that is an alternative to the more complex dot matrix display. They are most commonly used in digital clocks, electronic meters, display, and so on. In calculators too. The internal connection of an 7-segment display is as shown. Each of the segment has an internally connected LED and a ground and a VCC is given. For a desired segment of number is needed, and you need a certain amount of voltage and ground is applied so that the output can be visible. Relay. The main function of a relay is to operate as a switch. It is an electromagnetic switch that opens and closes when voltage is applied across the coil of the relay. Here you can see there are almost 5 terminals in a relay. How a relay works is commonly you can see over here. First, let's see this one. Here you can see this is the normally closed one, and this is a normally open. So if you take a relay, you can see a normally closed and here normally open. This 2 point of a relay is a coil connected internally, that is shown here. From here to here, the coil is connected internally. The point 4, that is normally closed, is this position, and the normally open position is shown here. When the supply is given from the source to point B, A to B, it is not conducting. By controlling the switch, closing the switch, the coil becomes magnetized and it pulls over the lever B and makes a contact. According to it, by controlling the switch, we can control the operation of the relay. Hence, it is a control switch. Integrated circuit, which is full form of IC. In IC, the numbering of the IC can be done as shown here. That is, in every IC there is a notch provided as shown here. Below the notch, the first pin which comes is pin number 1, 2, 3 and so on. Once it reaches 7 over here, the opposite to the 7th pin is 8 1, 9, 10 and so on to the last pin. Hence, we can identify the pin numbers on an IC. Here you can see an IC base over here. The IC base is used so that to protect the IC from getting damaged. That is, when an IC is soldered, if the IC is rightly soldered in an electronic circuit, there is a chances of that the IC may get damaged due to overheat. So initially we solder in the IC base. Once the IC base is placed, the IC is directly placed into the IC base without soldering. Hence, there is no heating of the IC and you get a protected process of placing the IC. The next is the fuse. The fuse is a circuit breaker. It is used for the purpose of protecting the device from short circuit or overload conditions. The fuse wire may be made of a zinc or a silver or an aluminum, which is drawn into thin wire and they are soldered into the end caps of the fuse. Fuse ratings depends upon the thickness of the length of the wire used. For a certain fuse, you can see over here, end caps are there. On the end caps, you can see the ratings of an ampere and voltage of a fuse. Heatsink is an device that is used to absorb the heat from the device that it comes in contact with. It is used in computers for the cooling purpose of the central processing unit of a graphic processor. It is normally made of aluminium or any metal that that can absorb the heat from the devices from which it is comes in contact to. The common heat sinks are shown here below.